Hello and welcome to this cheeky little overview of the current state of HelixLib, a mod system for Vintage Story that implements Lua scripting into C Sharp pretty natively. We're going to be covering pretty much what the core mod does, different configurations of it, and getting started with writing our first Lua mod. Wouldn't that be fun? So the first thing, the entry point for this, please excuse the mess. Um, so the entry point for HelixLib is right here under HelixLib.cs. This contains our mod system and some handy little helpers that I will explain later. So this is our mod system. We step in, uh, define some like little custom thingies, and then for starting pre, we want to just quickly set our API. It doesn't matter so much. Doesn't matter. Another if debug tag. I'll get into that again later. And then we jump into registry assembly. So assembly registration. So we jump in here. I restrict interop pretty hard to try and minimize the access of Lua scripts, so you won't have access to things like OS, but I'm certain if you wanted to find a way around the sandbox, you will. Um, that's kind of annoying, but that's just how it is. I mean, you've got the whole of C Sharp, and that's not really sandbox. So we step in and we register our custom type. So this is just some stuff that Helix has access to, but we'll see that when we jump into the Lua. So we assemble all of the registry stuff. You know, we tell Moonsharp, hey, let's register this assembly. And then if our type's registered, if it's within the blacklist, so anything from System, Microsoft, and Newtonsoft, because we use our own Lua specific uh, library for that. It's a lot simpler and cleaner. We will effectively just skip over that. Otherwise, we'll register the type and add it to our list of global types, which are going to be used within the Lua context. And everything else in this file relies on output annotations. So if output annotations is true, so if this value is true, it will create a folder in your mod config and spit out Lua ls type annotation. Like there's a lot of shit in here, so try not to think about it. I've already bundled the annotations with the uh, dev version that is going to be released. So there's going to be like two concurrent versions. It's going to be HelixLib, which is, it doesn't contain any debug. It's just, HelixLib. It's just meant to run the mods. And then the dev kit, that will contain annotations and VS Code debugging out of the box, which I will show you again later. So after line 3 or something like that, we set up the sandbox. We set our base mod path to mods, and then for every single mod directory within our base mod path, which would be effectively, HelixLib slash mods or HelixLib underscore devkit slash mods. If the mod exists in there, we'll just load that mod into our mod loader, which is just a big list of um, no definition for load mod. Sure, mate, sure. So it pretty much just comes in, sets a bunch of paths, ignore global Lua path because we don't really want to be, you know, if you have Lua installed on your machine, it's preferable that you um, add it to Lua libraries or bundle it within your mod itself as something that you require. Simply because you know, it causes like dependency issues between different users. If, you know, one mod is using a specific library and another mod is using a different specific library that's not within Lua libraries, like not within the core, then yeah, it'll cause a couple of issues, and that's never good. So the first thing we do is we create this table with modinfo and modinit in it, and we set a global called Helix to that table. So at this point, there's a global that exists called Helix, and it has a modinfo and a mod init. And then we load our modinfo.lua and our modinfo.lua, and we just convert the types back to C# from there, and we put them into a little bit of a list after, you know, loading all the mods, checking your subdirectories, and pretty much just getting your mod, if that makes any sense. Um, Fantastic. So once we've added the mod, you know, we'll get a little print saying, hey, you know, our mod loaded, good. And then we return the Helix mod. Just for debugging purposes. It'll normally just return null, so don't even worry about it. So we just discard the return result here because we're not in debug. Otherwise, we would attach our debugger at this point. We also set up a file system watcher for the base mod path. So every single file that gets changed within the mods, if the file is changed specifically, all of these other ones, so uncreated, deleted, renamed, doesn't have any fantastic functionality, like custom functionality for package reloading. But on changed, will do some specific things, like hot reloading your packages, like effectively saying, like the result of require. So whenever you require a Lua file, it caches it. So what this does is it just says if our file is changed, like clear the cache for this package. So that just means we have hot reloading with things that use require, which is quite good. Again, more debug stuff for listener clients and stuff like that. If we're in the dev kit, it is important to know that I have made an error. I will add, in fact, right now. Never a dull moment. So if you've got debugging enabled, you'll be able to see all of these events that are popping up while you're like starting to run the dev kit. And when you see this, you'll jump into your mod and you will connect the Moonsharp server, and then it will continue and be completely fine, and you'll be able to hit your breakpoints. So once all of that is done, so once we've set up the mods and we've loaded pretty much all of the stuff, we come down into where we set up all of these callbacks. So for every single one of our mods, we'll switch case and we'll say, okay, our initialization callbacks are equal to the ones within the mod init that we set. So start pre, start client side, server side, all of these different options for us. Otherwise, just don't even bother. And then for every single one of those callbacks, we'll call it using Helix mod's script. So the attached script for the mod itself, not a Lua script, a Moonsharp script, which is like a brain for the entire mod effectively. So it's calling this mod's value. And I'll show you how that all works probably right now. Hello, it is me in post. I forgot to mention important extensions that you will need for your VS Code in order to do Lua debugging effectively. So the first thing you'll want is Lua language server. So it's just this one, 44, 1 million. It's all good. And Moonsharp debug, which is a debugger for Moonsharp. It's not widely used, which makes sense because out of the box, it's pretty garbage. So you have to do a lot of finagling to actually get it to work and hit your breakpoints. But once those are done, you can come up to your VS Code up in here. So this is where our mod is in post. I will show you all of the directory stuff, but you want to come into launch.json, which I will commit with this example mod, and it effectively has two configurations: Moonsharp attach server, and that starts a Moonsharp debug request to attach on 41912. 41912 is the server thread that is running in the C# stuff of Helix, and 41913 is the client stuff in Helix. So when you are running a Helix dev kit thing, what will happen is it will start, it will wait, and you will come over here, you will run and debug, and you will attach whichever one it tells you to attach. If it hangs after you've connected your server, it means you probably also need to connect the client at that point. So you would come in here, you would press this, it would connect your thingamajig, click that, and it will connect your thingamajig. And mind you, I've got Vintage Story open on the other thing still. So I did, in fact, manage to attach them because the thing's running, and easy peasy, lemon squeezy. It's mainly for debugging your start scripts is why the thing pauses. So once we call Moonsharp attach for the first time, chances are you'll step into the first breakpoint. And let's just get back into the video because now that I've explained it, that should be all good. So once again, Moonsharp debug and Lua language server for your type annotations. So this is our mod. We have our modinfo.lua here. This is for Lua LS type annotations. So Lua LS, fantastic, lovely, love it. So the fact that we're using type annotations means that whenever we hover over something, we have a lot of access to, the values that it has, the functions, pretty much like we have just IntelliSense for this Lua stuff. Right now, the version dependencies don't really do anything, neither does the description. But it's, again, a work in progress. We're getting there. So once modinfo is read, it will read your mod init. And this is where things start to get interesting. This is where code starts to happen. So this is a good place to have global requires. So if we have a thing that we want to add to our initialization and be accessed within every single script that we want to require, all we have to do is come in here and say inspect is equal to require inspect. And mind you, I will explain very quickly that Lua libraries and annotations here, I will open the containing folder. So the overall structure is a typical mod. Like this is the dev kit here. But annotations and Lua libraries are in the top level of this directory. Once you step into mods, we'll see this. This is where we are in here. So we step in again. Annotations and Lua libraries are symbolically linked. There might not be an equivalent on Windows. If that's the case, simply copy and paste annotations and Lua libraries in here and add them to a git ignore. Do not commit your mod with the annotations and Lua libraries because we don't want to double them up. So I've created these dynamic links. So we jump in and pretty much this is like it's back up here is where it is technically. So it's these don't exist, they're empty, they just redirect to a different file. So maybe there's a way to do it on Windows. I'm not 100% sure. I hope you find a way. So our mod init uh, does not reload if saved. So this is not going to be reloaded if saved, because this is run once at the start of the application. You can't run it twice without doing a lot of workarounds, which will require you to re-register a bunch of hooks, so I've just not allowed it. But that's completely okay, because this is just defining entry points and stuff like that. So we say helix.modinit, and it's equal to this new table. We can hover over here and we can see we have access to assets finalized, assets loaded, start client side. But we're going to be looking at start pre. So before we do any client side or server side stuff, we will require shared start pre. So we jump in, and this might look a little bit complicated, but I will explain what start pre looks like. So we have a module, and we have a meta table, effectively. So we're saying we've got this module, we'll set it as a meta table, which effectively means that we can access wacky little things, like when the whole module is called, we execute everything within here. And so what's happening is, within modinit, when we require start pre, what's happening is it's returning the meta table that has this call function, and we can call the entire script effectively at that point. So when we do the call from Helix, so once we do script.call, it's actually calling that little module in there. So that call links to this call and will run this. So what does that mean for us? So we have this thing, it's called start pre. We linked it to start pre, and it's going to run in start pre. So this is going to start pre, which means when we start pre, starting to get tired of fucking saying it, what happens is we do a little just debug JSON encode. We say test is 1, thing is 2, and that's our little JSON result there. And JSON is a function that we declared, or rather it's a module that we declared up here, and we've got access to it all the way down there. Which is good. It's fantastic. And then we have a couple of little Helix helpers here that I've written. So we can log JSON. And what JSON will do, like helix.log.json, is if we have a JSON encoded object, and mind you, if you try and JSON encode a table with a function in it, you will full crash. So try and put it in an XP call, effectively like a Lua try catch, and see if you can actually JSON encode it before trying to do anything with it. But what JSON does is it just unescapes the string, so it can actually print into the logger proper. Additionally, what I've done is I have turned the print function. You might think, oh, this is just going to go to the Lua REPL. No. What print does is I've hijacked it, and what it does is it prints to the API logger debug. So we'll be able to see things if we're running, from here. So if we run HelixLib from here, we'll be able to see everything within our integrated console. Yeah, just like this. So it's just stuff like this. And that's all good. So it just hijacks the print function. So you can just use print, and it'll be quick and simple, and you'll be able to see it. Cool. Now here we start making a lot more use of our type annotations. this doesn't do anything. Like this line here doesn't exactly do anything, but we need to say that an API, like even though we understand the global is set, Lua doesn't know that the global is set. That's why we're using type annotations. So we say type is an iCore server API, or it could be an iCore client API. So we just have access to both of the groups of functions within both of those. We could just as simply, if we are not within a shared script, just declare it as, iServer, like iCore server API if we're in like a server function, or iCore client API if we're within a client function. Or if it's like a client-side initialization or a server-side initialization. These names are important, CL underscore, SH underscore, and SV underscore as well. So I should probably move these out of here. Here we go. Yeah, yeah. I don't know if that's going to break anything. I don't remember if I was testing with much of that. But, doesn't matter. Does not matter. So now we have stepped in our start pre, and we can check if API side is enum app side server, and we have type annotations for all of these. So to demonstrate that, API.side will return an enum app side, and then we can do is equal to, oh, that's nifty. I didn't know it would do that. But yeah, we have access to all of these enums just out of the box, like straight out of the box. I think we even have GL keys. We can do GL keys dot B. Yep. I'm pretty sure, yeah, I'm pretty sure I have all of those types added. So if we wanted to do an event on keyboard down or something like that, it'd be super duper easy to do. Um, so what this does is if it runs through on the server side, it will print uh, to debug that Helix has started the server side pre-run. That's all good. So it doesn't really do anything on the server side. But the second it comes through again on the client side, it will step in here and register this event listener. So this game tick listener that will run every 5 seconds. It will perform this function. And so in this function, we say counter is equal to require client.counter. So we have to do these dots. We can't do forward slashes with require. And since I've hijacked require to be a lot more functional and useful for code reloading and hot loading, please try and keep to the syntax. So let's have a little look inside client counter, see what it does. We initialize a local count table that has a counter value of 0, so that's the initial 0. Message saying 5 seconds have passed, and an increment, which is just 1. And just for debugging purposes, I've put API show chat message, reloaded the CL counter file, just to show you that this is, like, you don't need to return it as a module. You can just require the file, run it once, set up a bunch of event hooks, and you're good and done. But in this case, I wanted to keep it as modular as possible, just for this example. And so our count table, so this count table module that we have, we want to perform a function on itself. So we want to do count, and we want to pass it its first variable as self, which means we can use the self keyword in here, and we can just check and see that, yeah, we've got a self. Yeah, we don't need this anymore, probably. Cool beans. So what we'll do is effectively step in require this file, so it does our first little initialization. This will return do count, which is a function, and a couple of different variables up here. And then we'll call do count with this colon operator, which will pass the counter that has been cached in require into do count, which will effectively say the counter that we handed it, we want to set that counter plus the increment and then show that counter's values. I'll save this quickly, save that quickly. So what that does is it says, we'll get the cached counter, so it might have a different variable in its counter. It might have a value of 500. It could have been running for quite a long time. So it'll just require the one that has been cached with and package loaded, step in, count, 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 and do that every single 5 seconds. So enough dilly-dallying. Let's quickly cut to starting the server with HelixLib DevKit enabled. Okay, I am back from fixing up those changes. So I've moved the dev build to the correct location. So I've just replaced everything in here with the new DevKit build, which contains the little prompts for us. So let's start up Vintage Story. And hopefully you can see this. And we can see that we've got the Helix DevKit enabled, which is HelixLib, but with debugging enabled for testing your mods, which is good. So we'll come in single player and we'll just go debugging. So it'll load, it'll say, yeah, you know, we've loaded all these things. And now to please connect your Moonsharp server debugger. So we will go ahead and do so. Up here in the run and debug, we come down and attach the server debugger. And instantly it starts the start pre because we call the function and we had the script loaded, so we just instantly step in. So lovely dovely, happy to see it. We've probably even got a call stack coming from an unknown source, which is probably our C#. Helix print JSON. We can't see the logs right now, but it's certainly printed out to the debug section of our logs. We can see that our API is itself still, so this is still just a type annotation. And then we get our side, which will evaluate to server side. So print Helix server side start pre-ran. Easy peasy. And there's nothing else for it to do, so it will step out. And that's it. We'll just continue to run. We'll jump back over here. If it hangs again, chances are it's because it's trying to print the log client side. So we'll jump over here, come Moonsharp attach the client this time. So start debugging with the client, and instantly we get the hook again. Step in, step in, step in. This will print hello and the JSON result for the client now. Our API side is client, so it will step down here and register this game tick listener, and off it goes. Then we can remove that breakpoint and we can put it down in here. Now we'll just continue to run. Custom server message, love to see it. Now we've hit that 5-second mark, and we're going to require CL counter. So counter right now, it doesn't exist. So now it equals to requiring that counter. And then we step into do count. I'll press F11. So we've stepped into do count, and our self counter is 0. So we'll set it to plus our increment, and then we'll show the chat message. And then I'm pressing F5 because we had a couple backed up. Okay, I'll remove the breakpoint from that now. As you can see, reloaded the CL counter file. It happened because we loaded the file just once. So if you want to do some just once off sort of things, you can just require the file. You don't need to call a function within the file or from a module. You can just keep it clean and simple. So now we have this neat little thing where it's running, our debuggers are attached. If we want to hit a point in our code within do count or something like that, we just have to press F9. So we press F9 and off you go. Show chat message, we can see the message, 5 seconds have passed, counter is 0 times. Yeah, that's all well and dandy. But let's make it a little bit more fun. We can say that 5 grundle have bacon. Tomato. So now the message is 5 grundle have bacon. So that's 5 grundle have bacon. The counter, which will be reset when the file is reloaded. So I'll put a breakpoint in here after saving the file. So I'll save the file, put a breakpoint in. Reloaded. Hello? There we go. Yeah, it just took a sec. So we reload, we do counts. And as you can see, the hot loading is working fine. You can see our self has a table, it's got an ID, and we could pretty much just do all of the fancy little things that we needed to do. We can even see the call stack, but when it's like anonymous through require, it's not supported. So yeah, maybe you have to put the breakpoint just in this section here and then step down into where you want to go. Maybe if I press F5, yeah. No, you got to step in from the root section here. So where the events are being called, you can't just put a breakpoint willy-nilly, looks like, because like I said, it's going through an anonymous require and doing a weird thing in a weird location. So it doesn't really know where CL counter is. It's part of the script there. But the file itself knows how to be reloaded, which is quite good. So once we're in here, we have a lot more control over our breakpoints and stuff like that. So I'll show that again. So I'll put a breakpoint here. I'll press F11, and then if I were to have a breakpoint down here, maybe, and I press F5, nah, that's something I'll have to look into, I think. Yeah, because it's probably creating a temporary file based on the require. So it's not the real file that's being called. But that's all right. So as you can see, we've got file hot loading. It will reset the values to the base value. So be cautious if you're setting anything very, very specific. Try not to reload the file because you will lose the cached file. That is kind of where Helix is at the moment. I'll show you some stuff that's not exactly ready and or functioning. This is purely like the pseudocode tangent for Helix. So if you don't care about that, you can just check out now. I will not fault you for that because this code hasn't been tested, hasn't exactly been working, but still, it's something potentially worth looking into. If we were to do a do file, we can hand it a specific file. So this wouldn't return CL print hello world. So we're not going to use do file in pretty much any case. So we're never going to be using do file. Let's have a look at server test. What does this do? Cool, cool. This is where I was testing very early versions. So what happens here? I can probably uncomment this. All we would need to do is we can go chat commands dot create. Yeah, I need to figure out a good way to do constructors for this. But then again, I can probably just get away with removing this delegate here. Yeah, calling customized methods effectively. So this is one of those things where it's you need to create a binding in C# for weird specific delegate handlers. That or figuring out a way to make the generics less generic. You could probably just as easily completely ignore these warnings, which is something that you could likely do because Moonsharp will probably do its best to try and uh, be okay with what you were doing. So maybe I can do something like local test thing, or rather test args is equal to on command delegate, maybe. And then maybe I could just hand it some methods and stuff like that by setting it up as a table. But I'm not 100% sure, which is fine. But the idea is you're able to get, like since this is on the server side here, so server core API, which should actually be API in this case, but we type it. So we don't know what API is in this case, but since we've defined it, we have access to both iClaw client API and iClaw server API because in start pre, we went ahead and just did that. So if we come back to the server test, we have chat commands, create, new command name, and then we can do with description, handle with, and then in theory, it should work. Print event is if me testing a bunch of different functionality with effectively threading, so like Lua coroutines and stuff like that. I have, instead of doing all of this crazy coroutine stuff, created a coroutine helper since I've been working on this, so I can do helix.threads.get instead of threads. This will make sense once I explain it. So co is equal to threads.get, and what it does is it searches for a list of C# coroutines that we have created and assigned to the threads thing. So we can add a thread, which is a function, or we could get like all of the threads with a specific name. So pretty much like if we don't have this, so if we don't have this thread, we want to step in because if it'll be null, or nil rather, and we say co is equal to coroutine.create, and it performs this lambda function here. And this is asynchronous. So what this would do is from 0 to 5, it will print coroutine has resumed has the value of I, and coroutine yield. So what yield does is it effectively puts this coroutine on pause. It says, no, this is pause now. So we can create this coroutine and we can run the coroutine, but it will only say I is like 0, and then it will freeze forever because we haven't resumed it in a loop of some kind, or a game thread or anything. So we get co, which is coroutine like create, and that returns a thread. and we can add a thread to the list of threads using thread add, give it a name, and we give it its current status as well. And that will just push it back into the list of coroutines. And now we can do, like, if the thread is dead, then we print that the coroutine has, well, died. And at the end of this file, assuming that this CL print event is running within like a game tick loop of like 1 second. So like we have in start pre, if we registered a game tick listener for every 1000 milliseconds, and we run this file every second, what that will do is it will come in, it will get the new coroutine that we've created, which exists, and it will say, no, it's not dead, and then it will resume the coroutine, which will cause it to come in here and increment I and yield again, and do that over and over and over again until the coroutine is completely done. So that's a nifty little thread helper that I've written to make coroutines actually function as intended. I think Moonsharp actually has a thing for that, but I'm not 1000% sure. Other than that, this is again me testing with event hook callbacks. This is bad. Ignore this. This is also bad. This is also bad. This one's okay. This one's pretty okay. So if we were to require CL event key up and call it, what would happen is it would step in. We wouldn't need this anymore, so we don't need this. We don't need any of this. Oh, maybe we do. Yeah, because this is from like when I was doing event testing. So when you call a vintage story like event, when you add a new event, there was a fancy little thing you could do with variadic arguments, and pretty much say that, yeah, our API is equal to, you know, this from varargs, so it's the second element out of varargs, and the key event is the third element out of varargs. But it would just be the second element because we don't need the API, because we already defined the API globally way outside of all of this, so we don't need this specific thing anymore. Doesn't matter. This is not hooked up. I need to do some testing and figure out what's going on with that. But we can effectively say that key event from these variadic arguments, again, we have full IntelliSense. You're welcome. Key event key code will return a key code and glkeys.u. So whenever you press the U key, like if this evaluates to true, we can just do API show chat message because we're in client, which means we can just do API.show chat message. You have pressed U lamau te, haha. And that's just a little thing you can do to get like keyboard hooks and all of that sort of thing. Ideally, instead of doing this, you would define a new event register up in here. So if our site is client, we wanted to do API event dot key down or key up, which will have a key event delegate. We can do API event key down, and what that will take is a key event delegate. But again, we can probably just say that it is a key event and have key event like that. We might even be able to do this param key event is a key event. Is it a delegate or a handler? It's a delegate. So key event should be a key event now, but that doesn't seem right. Maybe it's just a handler. Yeah, because it's a handler, so we want to be able to get the no, not that hand. No, I think it's just straight up a key event, which would make even more sense. Yeah, then we've got access to all of the key chart and all of that. So we can just quickly and easily do if key event dot key code is equal to gl keys dot d, I suppose. Then API show chat message pressed D. So whenever you press D, um, it'll just quickly check and off you go. Like that's it. Like it's very, very simple, quick, and done. Right, and that pretty much sums up where I'm at. I still need to do a lot of testing with the Lua specific stuff. Um, yeah, but I'll do that off camera. If you have any questions or anything like that, please feel free to hit me up on the Discord, uh, or leave a comment on this video, or create an issue on the GitHub, or do this or that, or the. It doesn't matter. Just get in touch. I hope this was useful, and I'm hoping that I've got something quite good and ready to go pretty soon. Alright, thanks for watching.